Welcome to the electromagnetic theory and interference course. In this session, we will see about wave propagation in lossless dielectric, and we will solve one problem based on that. So in lossless dielectric, we already know that conductivity is very less when compared with omega epsilon, and it is a special case of lossy dielectric if conductivity is assumed approximately equal to zero, because there will be no conductivity there. Permittivity and permeability, it's similar to the lossy dielectric, where it depends on free space as well as relative one. Okay, now we've used in each of the cases we have to find what is alpha, beta, velocity and intrinsic impedance. Okay, so now we are substituting conductivity is zero in this attenuation and phase constant expressions we got earlier. If we substitute in alpha, we get this term as 0. So root of 1 minus 1 is going to be, entire term is going to be 0. Whereas in beta, it is going to be 1 root of 1 plus 1. That is, you will get 2. 2 and 2 get cancelled. We get omega into root of mu epsilon. That is the answer. So what is velocity? It is omega by beta. If we substitute the value of beta, omega get cancelled. We get 1 by root of mu epsilon. Wavelength is same, 2 pi by beta. When we go for intrinsic impedance and substitute conductivity at 0, this term get vanishes. J omega is cancelled. We get root of mu epsilon. Angle is 0. That means electric field and magnetic field are in time phase with each other in case of lossless dielectric medium. Okay. Basic thing is the conductivity is 0. With that, we have to find rest of the terms. So coming to the given problem, they are given a lossless dielectric for which intrinsic impedance is given as 60 pi, relative permeability is 1, and magnetic field expression is given. Okay, it has two components along AX and AY, ampere per meter they have given. We are supposed to calculate relative permittivity, okay, then angular frequency omega and the electric field. So in lossless dielectric, we know conductivity is 0, so alpha is 0 and beta equal to 1. Okay, and with that we know eta intrinsic impedance is root of mu by epsilon. So mu is nothing but mu naught into mu r, root of mu naught into mu r. Epsilon is nothing but inside that root itself we have to write epsilon into epsilon r. And we know that this is the free space um, character intrinsic impedance, that is equal to 120 pi. Okay, and mu r is 1 given, so the denominator term I have to put root of epsilon r. So epsilon r is the unknown quantity, eta they have given. So if I take to the left hand side, we get root of epsilon r is 120 pi divided by 60 pi. So we get 2, and then epsilon r going to be 4. So we have found the first component. Now to find the omega, we know beta equal to omega root of mu epsilon. Same, I am going to apply omega into root of mu naught into mu r, epsilon naught into epsilon r. So if we rearrange and take this term is going to be 1 by velocity of light, right? So omega by c, this term, and root of 1 into 4 is root 4. So if I want to find the omega, it is nothing but beta c divided by 2. Beta is from the given expression, we can find omega t minus beta z, right? So beta is 1 here into velocity of light value divided by 2. We get 1.5 into 10 power 8. What is the angular frequency? It's radian per second. Now the last component is electric field. We know that uh, magnetic field is given as a vector sum of two terms, right? Similarly, the electric field will be, what is the change means? The magnitude will change, the function will remain same, cosine and sine function, the unit vector will get changed. And we can notice that magnetic field itself has the components of AX and AY, and wave propagation is along the Z direction, and um, we don't have any component along the direction of propagation. Okay, it is called a transverse electromagnetic wave. Let us find the unit vector in this electric field to find the electric field expression. and also the magnitude of the electric field for both the components E1 and E2. So we know that AE is equal to negative of AK cross AH, and since it is the first term, we are writing AE1 and AH1. And if we see the given expression, the direction of wave propagation is in positive z direction. So AZ cross AH is going to be negative AX because negative sign is there. So if you substitute, we get the answer as AY. Already one negative sign is there and one more negative, so positive AY. Similarly, for the next component, it is minus of AK cross AH2. So AK is same AZ, and AX and AH is going to be AY. Z cross Y is what? Is nothing but minus AX, and along with this negative, it is going to be plus AX. If I want to find magnitude part of electric field, we know the relation eta is equal to E by H. From that, E is equal to eta into H. Eta is given in the question as 60 pi, and if you multiply with the first magnitude of this component, zero point 0.1, we get 6 pi. Similarly, for the second component of electric field magnitude is eta 60 pi into zero point 0.5, that is 30 pi. And if I substitute the unit vectors and amplitude in this expression and sum up both the things, we get the answer in volts per meter after substituting the omega terms, okay, as well as multiplying 6 into pi. I hope you understood how wave is propagating in lossless dielectric, and we have seen how to solve a problem given based on that. Happy learning. We will meet next time.